Hello and welcome to the GCSE Science Tutor. Today we are looking at Lesson 12, Transition Metals, which is a triple-only lesson. The transition metals can be found in the centre block of the periodic table. And I recommend that on your periodic table you annotate this block of elements. So it's the ones that I'm highlighting here and label them transition metals. In an exam, you are going to be asked to discuss the physical and chemical properties of both Group 1 and transition metals. So what is the difference? Well, a physical property are those that can be observed without changing the chemical identity of the substance. What that means is it's something that can be observed without undergoing a chemical reaction. For example, density or hardness or melting and boiling point. However, a chemical property can only be observed by changing the chemical identity of a substance, i.e. when undergoing a chemical reaction. For example, flammability, you must set a light to the substance. Reactivity, you must react it with something, or its use as a catalyst, again, that's within a chemical reaction. So that is a chemical property. You are likely to be asked to compare the Group 1 metals and the transition metals. The Group 1 metals, as the name suggests, are found in Group 1 of the periodic table, and the transition metals in the centre block. Examples of Group 1 metals are lithium and sodium, which we saw in Lesson 10, and the transition metals, good examples are gold, silver, copper, iron, and titanium. So let's first focus on the physical properties. In Lesson 10, we had a look at the Group 1 metals, such as lithium, sodium, and potassium. Here is sodium being taken out of a jar under oil. It is soft, it can be cut by a knife. And like all other metals, can conduct electricity, as shown by the light that has turned on here. Sodium also floats on water because it is less dense than water, and melts into a ball because it has a very low melting point. And now the physical properties of the transition metals. Most of the transition metals are solids at room temperature, aside from mercury. They are hard, and shiny, as can be seen here. Some gold and silver. We can also see the transition metals here, sheets of copper being hammered into sheets, which means they are malleable. Copper being drawn into wires, which means they are ductile. The metals can be set up in a circuit to be shown that they conduct electricity, like all other metals. They have very, very high melting and boiling points, as can be seen here. For example, bronze has a melting point of up to 1000, gold 1063. Tungsten, which is found in filament lamps, has the highest melting point of 34,222 degrees Celsius. Using the information from the previous videos, I would like you to draw the Venn diagram below and add the statements from the list in the correct position. Pause the video now and I'll go through the answers on the next slide. So hopefully you got something like this. Transition metals have high melting points, high densities and are hard, whereas group 1 metals have lower melting points, as shown by sodium melting, low densities, as shown by them floating on water, and they are soft, they can be cut by a knife. Both group 1 and transition metals are good conductors of electricity, are shiny, and are good conductors of heat. Now let's focus on their chemical properties. In lesson 10, we had a look at the reaction of the group 1 metals with water. And a reminder here, they are extremely reactive. In fact, rubidium and cesium are highly explosive and produce lots of flames and sparks. Group 1 metals are found near the top of the reactivity series, with cesium being the most reactive. Below group 1 are group 2 metals and group 3 metals, with the transition metals found at the bottom of the reactivity series, meaning they are the least reactive metals. In fact, silver, gold and platinum are found at the bottom, and they are made into jewellery for that reason, because they don't react with water or very, very slowly with the oxygen around in the air. Other chemical properties include the colour of their compounds. As can be seen on the left here, transition metal compounds are all very colourful. For example, iron chloride is a bright green, copper sulfate is a bright blue, whereas group 1 metals compounds are all white. For example, sodium chloride, which is table salt, is a white crystal. Other group 1 metal compounds are all white, and none of them are coloured. Another key chemical property difference between group 1 and the transition metals is the charges on the ions, also known as the oxidation states. From previous lessons, we saw that group 1 alkali metals will only form positive 1 charges on their ions, and that is the same all the way down the group. However, transition metals form variable oxidation states or variable charges on their ions. For example, copper can produce a copper 2+ ion or a copper single positive ion. Iron also has 2 oxidation states. It can form a 2+ ion and also a 3+ ion. Other transition metals can form even more oxidation states. For example, manganese can form a 2+ ion all the way to a 7+ ion. The 2+ ion and the 7+ ion are one of the most common oxidation states, with 3+ and 5+ being the least common. Here we can see the manganese ion, which is a purple colour in one of its oxidation states. When reacted with a sugar sodium hydroxide mixture, it can transition through various oxidation states, changing colour along the way. For example, some oxidation states are green, and will now move into a different oxidation state or charge on its ion, which is more of a yellowy colour. Catalysts are something that speeds up a chemical reaction without getting used up in the reaction. We will look at this further in a future module. However, transition metals are really useful catalysts. For example, iron is used to make ammonia by the Haber process. Platinum is used in the manufacture of nitric acid. Rhodium and platinum are used in catalytic converters in cars. Nickel is used to make margarine by hardening vegetable oil. And vanadium 5 oxide is used in the contact process to make sulfuric acid. Group 1 metals are not used as catalysts. So using the information that we went through in the previous videos, again, draw the Venn diagram below and add the statements from the list in the correct position. Pause the video now and I'll go through the answers in a few moments. Transition metals have low reactivity. They react slowly with both oxygen or water, whereas group 1 metals are very reactive and react very quickly with water and oxygen and nonmetals. Transition metals are used as catalysts, whereas group 1 is not. Transition metals have ions with different charges, whereas group 1 metals only form a positive 1 ion. Transition metals have coloured compounds, whereas group 1 metals form white or colourless compounds. Now to see what you have learned. Pause the video now and make a list of the statements on the screen which are true and those of which are false about the transition metals. I will go through the answers in a few moments. A. That is true. Transition metals are found in the middle of the periodic table. B is false. Examples are nickel, vanadium, and cesium. Cesium is not a transition metal. It is a group 1 metal. C is also false. They do not have low melting points. They have high melting points, the only exception being mercury. D are usually dense or heavy. That is true. They will also sink in water. E is also true. They are usually ductile and can be stretched into wires, such as copper wiring. F is also true. They have lots of uses, including being used as catalysts to help speed up reactions. G is false. They are not good insulators, they are good conductors of heat and electricity. H is true because iron, silver and titanium are all transition metals. I is also true. They are malleable and can be bent into shapes. J is false. They are not found in group 1 and 2. They are found in the middle. K is true. They are hard. L is false. They do not form positive 1 charges. They form variable charges. M is true. They are all solids at room temperature, apart from mercury. N is true. They produce coloured compounds. And finally, O is also true. They are good conductors of heat and electricity. We have now finished Unit 1 and will be moving on to Unit 2, Bonding Structure and the Properties of Matter, Lesson 1, Ionic Formulae. Thank you for listening to the GCSE Science Tutor. Please remember to like and subscribe to get further updates on lessons and tutorials.